Imagine a world where summer doesn't just feel hot, it feels hostile. Now, drop yourself into Baghdad, 1200 AD. The temperature hits 120 degrees, the air shimmers like liquid fire, and stone walls radiate heat strong enough to burn your hands. It's the kind of heat that would shut down a modern American city in a single afternoon. But inside the royal palaces, it's cool, comfortable, refreshing. And here's the part that breaks your brain. There's no electricity, no fans, no ice, just a handful of Persian engineers who refuse to accept the rules of nature. They build towers that trap the wind, crush the heat, and create a temperature drop so dramatic, 40 degrees, it rivals the best modern air conditioners. All with clay, wood, water, and physics so clever it feels like cheating. This isn't ancient magic. This is engineering brilliance that survived 800 years. And the wild part is, you can recreate the exact same system today with $50, a box fan, and 15 minutes. If you think ancient people were primitive, think again. Because the Persians didn't just beat the desert. They engineered a cooling technology powerful enough to challenge the modern world. Keep watching. The secret behind their impossible AC system is about to change how you think about heat forever. To understand why Persian engineers achieved cooling that still amazes us today, you have to step inside their way of thinking. They lived in one of the harshest climates on Earth, where summer heat wasn't an inconvenience, it was a threat. In Baghdad and throughout Persia, temperatures above 120 degrees weren't rare. Stone houses turned into ovens. Courtyards shimmered as if the air itself were melting. For most civilizations, this would be the limit of comfort. But for the Persians, it became a puzzle worth solving. Their engineering began with observation. Without electricity, sensors, or computers, their greatest tools were patience and an incredible sensitivity to nature. They watched how desert winds shifted throughout the day. They mapped which directions carried cooler night breezes and which funneled heat. They noticed how water behaved when left in shaded courtyards and how underground spaces remained cool even when the air above baked. Over generations, these observations became principles, unwritten laws of climate and airflow that shaped their architecture. At the heart of their cooling system was a simple revelation: moving air over water steals heat. We know this today as evaporative cooling, but Persians understood it centuries before thermodynamics existed. When hot, dry air is forced across a wet surface, the water evaporates. Evaporation absorbs heat from the air, causing temperatures to drop dramatically. And the faster the air moves, the greater the cooling effect. This understanding shaped everything they built. First came the wind catcher, or bajir, a tall tower designed not merely to catch wind, but to accelerate it. Persians learned that narrowing a channel increases airflow speed, creating pressure differences that draw hot air down into underground chambers. Once inside, that air met water stored in cisterns, tunnels, or shallow pools. The collision of fast air and cool moisture triggered rapid evaporation. What emerged on the other side wasn't just cooler, it was completely transformed. But the Persians didn't stop there. They discovered that surface area was the real secret weapon. The more wet material the air touched, the stronger the cooling. So they added textured surfaces, palm fibers, pottery shards, woven fabrics, anything porous enough to hold water. Doubling the surface area didn't just double cooling, it multiplied it. This attention to micro details gave their systems a power modern builders often underestimate. They also recognized the importance of insulation. Thick mud brick walls, shaded corridors, and underground rooms acted like thermal batteries. At night, wind catchers drew in cool desert air that soaked into the walls. By day, that stored cold radiated inward, helping maintain comfortable temperatures long after conditions outside became intolerable. All these elements, wind acceleration, evaporative cooling, thermal mass, worked together seamlessly. Persian cooling wasn't one invention. It was a complete ecosystem, a choreography of air, water, pressure, and stone. And what makes their achievement even more astonishing is how little it relies on technology. No compressors, no fans, no chemicals, just physics, perfectly understood and elegantly applied. When you grasp this mindset, you begin to see why their designs endure. The Persians didn't fight nature, they partnered with it. And in doing so, they built a cooling system so refined that even today, with all our modern tools, we can only recreate what they perfected centuries ago. To understand why the Persian cooling system was so powerful, you have to look at how the wind catcher itself evolved. It didn't begin as a masterpiece. It began as a simple tower, but every generation of Persian engineers refined it, studying wind behavior, testing new angles, reshaping internal chambers, until the structure became a fully optimized machine for controlling air. The earliest badgers faced only one direction, useful but limited. Over time, engineers realized the desert wind was unpredictable, so they rotated openings, added channels, and carved internal partitions. These weren't decorative touches. Each change altered the pressure, acceleration, and cooling inside the tower. Eventually, the Persians created multi-directional wind catchers, towers able to capture wind from any angle, any season, any hour. That alone transformed life in the desert. But capturing wind was only the first step. What made the system extraordinary was what happened beneath the surface. Persian cities built vast underground water networks, qanats, that guided cool mountain water into homes and palaces. These channels stayed cold because they were buried deep below the desert, protected from sun and heat. The lower chambers of a palace became natural reservoirs of chilled air. When the wind catcher funneled air downward, it collided with this cold, moist environment. The result was powerful evaporative cooling. Hot air entering the tower was forced through narrow passages, picking up speed. When that fast-moving air hit the water below, evaporation surged, stripping heat from the air almost instantly. The Persians didn't need formulas to understand this. They learned it through centuries of observation. They refined the process even more by adjusting airflow. Some chambers accelerated air, others slowed it down to increase evaporation time. Curved walls redirected drafts. Terracotta grills distributed cool air evenly across rooms. These structures weren't static. They could be adjusted depending on the time of day, shifting wind patterns, or seasonal humidity. A wind catcher wasn't a tower, it was a climate control system. What truly set Persian engineering apart was their understanding of the thermal mass. They knew thick stone walls could store cold. At night, wind catchers pulled cool desert air into the building. By morning, that cold was locked inside the masonry. During peak heat, the structure itself helped regulate the temperature. It was architecture behaving like a battery, charging at night, releasing comfort during the day. Even gardens and courtyards were part of the system. Pools added moisture. Shade trees cooled incoming air. Every element of daily life worked together, forming a holistic network that balanced heat and humidity. When you see the full picture, the genius becomes clear. Persians weren't just building towers, they were sculpting air. They were designing homes that breathed with the environment, structures that worked with the desert instead of fighting it. And what's most astonishing is this. The principles they perfected 800 years ago are the same principles engineers still use in evaporative cooling today. Nothing about the physics has changed. Only the materials have. Recreating the Persian cooling system today doesn't require a palace, a desert, or a team of royal engineers. What it requires is the same mindset the Persians used: control the air, multiply evaporation, and guide every movement of wind with purpose. When you understand those principles, the build becomes surprisingly simple. It begins with the wind. Persian architects always treated airflow as the foundation of their cooling strategy. In our modern recreation, that role is played by a simple box fan, but the idea remains the same. Air must enter the system with force, consistency, and stability. Set the fan firmly onto a base. It shouldn't shake, vibrate, or drift, because unstable movement disrupts pressure and kills cooling efficiency. In medieval Persia, a wobbling wind tower meant hours of lost labor. Today, it means a system that cools only half as well as it should. Next comes the structure, the equivalent of the ancient Badgir chamber. We use lightweight materials like foam board or styrofoam, not because they're ancient, but because they mimic the insulating qualities of the thick stone blocks used in the desert. The Persians understood insulation instinctively. Keep hot air out, trap cooled air inside, and prevent energy loss through every joint. That's why this step requires precision. Every panel must align cleanly. Every seam must be sealed. In medieval architecture, they used clay and straw to plug cracks. In our modern version, we use tape or adhesive. Different materials, same purpose. Once the frame is set, the airflow channels come to life. The Persians knew chaotic air is wasted air. Cooling occurs only when wind travels through planned pathways. So, we create directional channels inside the structure. Angled panels that funnel air smoothly downward, mirroring the narrowing passages inside a traditional wind catcher. Slight curves matter. Gentle angles matter. These details increase velocity and guide air toward the evaporation chamber with minimal turbulence. For the Persians, air was a fluid that could be sculpted. We follow the same belief here. Then comes the heart of the system, the evaporation surface. In ancient times, palm frond fibers, wet cloth, and porous pottery offered ideal texture. Today, a cooling pad made from synthetic fibers performs the same role, optimizing surface area for rapid evaporation. Position it at the system's center directly in the airflow path. If it's off to one side, you lose efficiency. If it isn't saturated evenly, the cooling collapses. Persian engineers checked by touch. We can do the same. The pad should feel damp, cool, and evenly soaked. To keep it wet, a simple water distribution line runs across the top. Modern zip ties replacing ancient rope. Drilled holes replacing clay nozzles. Water must drip steadily but lightly, just enough to keep the pad moist without overflow. Too much water, and evaporation slows. Too little, and the system dries out. The Persians solved this through years of seasonal tuning. We solve it by adjusting flow until the pad stays consistently damp, like a sponge ready to release cool air. When air meets this wet surface at high speed, the transformation is immediate. Temperature drops. Humidity rises slightly. Air becomes softer, lighter, more breathable. It is the same phenomenon that cooled desert palaces 8 centuries ago, replicated with the simplest modern tools. And when the system stands complete, fan humming steadily, water trickling evenly, airflow gliding through insulated chambers, you're not just building a DIY project. You're reviving a piece of engineering wisdom so refined, so elegant, that time itself couldn't improve it. The true test of any ancient technology is simple. Does it still work when stripped of myth, romance, and nostalgia? When this reconstructed Persian cooling system is switched on, the answer becomes undeniable. The moment the fan pushes that first burst of hot air into the chamber, you can watch the physics unfold in real time. It starts subtly. Air hits the saturated cooling pad, hesitates for a fraction of a second as moisture begins to evaporate, and then pushes through the chamber transformed. Within moments, the temperature near the output drops. 5 degrees, then 10. The air shifts from harsh and dry to cool and breathable. What feels like a gentle breeze becomes a stream of conditioned comfort, created without compressors, refrigerants, or even a closed environment. This cooling isn't magic. It's science operating exactly as the Persians predicted. Evaporative cooling absorbs heat as water transforms from liquid to vapor. The faster the air moves, the faster the evaporation. The more surface area available, the more impressive the temperature drop. In some of the great palaces of the medieval Persian world, this meant turning unbearable 120-degree desert heat into indoor temperatures that felt like spring. Our modern recreation isn't working with sandstone walls or subterranean water tunnels, yet the results still echo that history. In a room starting at 85 degrees, the system can bring temperatures down by 15 to 20 degrees within half an hour. It does this using mere watts of electricity. The energy draw is so low that it could run off a small solar panel or battery pack. That alone makes it a survival tool, one that outperforms many modern devices during heat waves or power outages. But what's just as fascinating as the temperature drop is the quality of the air itself. Modern air conditioners blast dry, recirculated air that can irritate skin, eyes, and lungs. Persian cooling, by contrast, adds a gentle lift in humidity, just enough to make breathing feel easier. It reintroduces moisture to air that has often been stripped of it by high heat. You feel it instantly. The air doesn't just cool, it softens. Then there's stability. The system doesn't degrade after minutes of operation. It maintains cooling for hours without strain because it has so few moving parts. Air moves, water drips, evaporation happens. Everything else is structure. The Persians built their systems to last decades, not years, and their principles create machines that keep running long after modern electronics fail. What happens when conditions shift? In hot, dry climates, anything under 60% humidity, the system runs at peak efficiency, just as it did in the ancient desert cities. As humidity rises, cooling output decreases, but it never stops functioning. This adaptability made Persian architecture incredibly resilient. Unlike modern AC units that shut down in extreme heat or power loss, the Persian design remained reliable because it depended on natural forces that don't break. When you stand in front of the output and feel the cool air flowing out, you're experiencing the same sensation someone in Baghdad felt 800 years ago. Not an imitation, an almost perfect replica. And that's the most astonishing thing. In a world of advanced machines, satellites, algorithms, and climate-controlled skyscrapers, a simple tower that uses water and wind still holds its own. That's not nostalgia. It's proof of how deeply the Persians understood the science of comfort. What makes this ancient Persian cooling system so remarkable isn't just that it worked 8 centuries ago. It's that it still fits perfectly into the world we live in today. Modern cities, off-grid cabins, tiny homes, workshops, greenhouses, every one of them can benefit from the same principles that kept medieval palaces cool under a merciless desert sun. The physics haven't aged. If anything, our changing climate makes this technology more relevant than ever. In regions with dry summers, the system performs almost flawlessly. Places like Arizona, Nevada, Utah, Colorado, inland California, states where millions rely on expensive air conditioning just to survive heat waves, could immediately reduce energy consumption with a design that costs less than dinner for 2. The simplicity is its strength. No refrigerants, no compressors, no fragile electronics that fail when the grid buckles under peak demand. just air, water, and controlled design. But practicality is only half the story. The Persian system scales beautifully. A small version cools a bedroom. A medium version transforms a workshop. A larger one can moderate the environment in a barn, greenhouse, or off-grid tiny house. Build multiple units, and they can cool an entire home the same way ancient Persians cooled palaces. Architects around the world have started reintroducing wind catcher-inspired designs into schools, museums, apartment complexes, and even research centers. Structures meant to last decades while consuming a fraction of the energy modern HVAC systems require. Other cultures took inspiration long ago. Egyptians built multi-tower wind catcher clusters to capture crosswinds from several directions. Spanish architects combined evaporative cooling with thick stone walls that store cold at night and release it during the day. Indian courtyard houses used clever convection cycles to pull cool air in and push hot air upward and out. Every one of these techniques echoes the same idea. Understand your climate, then design your home as an ally, not an opponent. And the system doesn't stop at basic cooling. Persian engineers even experimented with dual-stage cooling, adding ice or chilled water to the reservoir during winter months to create bursts of cold that drop temperatures by nearly 15 additional degrees. In a world where extreme heat events are becoming more common, this ancient practice suddenly feels visionary. What's astonishing is how well the Persian system adapts to modern emergencies. When the power goes out, whether during a heat wave, wildfire season, or grid overload, a simple solar panel or battery pack can power the fan. The entire cooling assembly draws so little energy that it can operate for hours on minimal power, offering life-saving relief in situations where conventional air conditioning becomes useless. This isn't just convenience. In extreme heat, it can mean survival. But perhaps the greatest legacy of this technology is what it teaches us, that innovation doesn't always require complexity. Sometimes the most brilliant solutions come from observing nature closely, respecting it, and designing with intention rather than force. Persian engineers didn't try to dominate the desert. They learned its rhythms and built structures that turned its harshest qualities into advantages. Standing in front of a working wind catcher system today, whether ancient stone or modern foam and fiber, you feel a connection that spans centuries. You're experiencing the same cool breeze that once drifted through the halls of Baghdad's palaces, the same gentle humidity, the same relief. And you're reminded that some technologies aren't just forgotten, they're waiting to be rediscovered. And that's the real legacy of Persian engineering. A system built 8 centuries ago in a desert with no electricity, no machinery, and no safety nets still stands shoulder to shoulder with modern technology. It didn't rely on power, it relied on understanding. Understanding wind, understanding water, understanding the rhythm of heat itself. When you recreate this system today, you're not just building a DIY cooler, you're reviving a philosophy. The idea that the smartest solutions aren't always the newest. Sometimes they're the ones hidden in history, waiting for someone curious enough to rediscover them. So, if this journey opened your eyes to what ancient engineers truly accomplished, imagine what else they mastered. Imagine what other forgotten technologies still have the power to reshape how we cool, heat, build, and survive. If you enjoyed exploring this forgotten masterpiece of physics, make sure to subscribe for more deep dives into ancient innovation and modern survival. And tell me in the comments, what surprised you most about the Persian cooling system? Until next time, stay curious. And stay cool the old world way.